P4 number 62. Here we're subtracting two fractions. Okay. I don't like the idea of subtracting fractions. Right? Just in the previous example, we flipped a division sign to get a multiplication by doing the reciprocal. I want to do addition. So I want to take this -1 and distribute it. I want to distribute it on the top because that'll almost always make my life easier, right? So we're going to get 2x minus 1 over x plus 3 plus minus 1 times the entire top. 1 minus x over x plus 3. Right? These two things are equal to each other. Now we have an addition. Okay? Now I can distribute this -1 through 2x minus 1 over x plus 3. I haven't done anything to the first term. Plus -1 times 1 is a -1. -1 times minus x is a plus x. Okay? All right. Now I am set up to do my addition now in a much simpler fashion. And the question I want to ask is, are my bases the same? In this case, they are. They're both x plus 3. And if the bases are the same, the addition goes very nicely. This becomes a fraction with an x plus 3 on the bottom. We take our first binomial, and add to it the second one. And since -1 plus x is addition, I'm going to flip that around into x minus 1 in standard form. Okay. Now this is a binomial plus a binomial. Now the orders don't matter here, right? I have a 2x, a -1, and an x and a -1, and I can break that up as 2x plus x with a -1 and a -1 all over our x plus 3. We have 2 x's and 1 x. 2x plus 1x is a 3x on the top. -1 and a -1. Well, we got two -1s on the top. And we have an x plus 3 on the bottom. All right. Is there anything else that can cancel? Well, I don't have a 3 on the top or on the bottom anywhere, so I can't pull that out as a multiplication. So that won't work. I can't cancel out my x's because, again, it's not a multiplication on the top and the bottom. So this is as simple as this thing can get without changing the function. Right. Now, of course, we always have a caveat, right? Is the bottom ever 0? Is x plus 3 ever 0? X equals -3 will have to be discluded, right? We're not going to get something because we'll have the unhappy 0 on the bottom. And that is our solution.